All right, here we go again, one more time, Hornets. We're going to look at Unit 5 here, Section 5.7, Exponential and Logarithmic form. And the goal for today is to be able to convert between the logarithmic form and the exponential form, to go back and forth. And one way of thinking about the relationship 2 times 2 times 2 equals 8 is 2 to the third equals 8. Okay? Another way to think of this relationship is the cubed root of 8 is 2. And then another way we can think about this relationship is log base 2 of 8 equals 3. Sadly, even though it's all the same relationship, there are three very different ways of expressing it. There is a proposal online to change this notation and make it more beautiful and logical. This new notation is called the triangle of power. And you can Google that and see another demonstration of it as well. But I hope to be able to present that clearly to you afterwards here. So, in the triangle of power, we got the triangle down here, triangle of power. The base, the number you multiply together, goes at the lower left. So when I look at like the 2, this like 2 up here, this 2 to the third, that number always goes here in the lower left. The exponent, like here we see an exponent of 3, that goes on the top. And that sort of makes sense because you kind of look at that positionally. It's like 2 to the third power. So what I like to think about is this line of the triangle is for reading exponents. The answer you multiply goes in the lower right. So 2 to the third equals 8. Furthermore, I like to think of this line right here as the radical. And that way I can think of that this 3 would go inside the hook. This number would go inside the radical. So I could say the cubed root of 8 is 2. And lastly, I think this best put this bottom line here of the triangle as the log. Because then what you can do is you can say that 2, log base 2 of 8 is 3. So it kind of fits this situation right here, that we got log base 2 of 8 equals the 3 across the path here. So let's just get a little practice at this and see how it all works together. So we got a couple triangles down here. You can see that this is the 3. This is like 3 to the fourth, because again this is like the exponent path. 3 to the fourth, and to get this number we just got to calculate that. 3 to the fourth is 81. Keeping with the same pathway here, this would be again the exponent path. 5 to the negative 2 is 1 over 25. Again, thinking the same way, this is the exponent path. 4 to the 0 power is 1. Over here, the path we have in between is the radical path. So again, I like to think about putting that into the hook. This number is inside. So this is the square root of 64, which is 8. Again, this is a little bit different, so we've got to think about this as a radical. Yes, we're putting that in there, and yes, we're going to put that in there, but we can rewrite that a little bit too as saying that this is the 1/27th to the negative 1/3. And if we evaluate this, we would see that that would be 3. The nice thing is we can always check ourselves too, like 3 to the negative 3 power, is it 1 over 27? And it certainly is. So again, think of this side as the radical side. This is the 5th root of 32, which is 2. Now this side, again, we're given the numbers down the bottom, so I'm going to think log down this bottom. So really what I'm doing is I'm evaluating log base 10 of 1,000. And again, this should be 3. This would be log base 2 of 1/2. And as we remember from previous lessons, we could write this as log base 2 of 2 to the negative 1. And if those are the same, we can put the answer right there. So again, think of this as the log path. We can rewrite this as log base 4 of 64. And again, trying to think of a way I can write 64 as a base 4. So log base 4 of 4. And that should be to the third power. Because 4 times 4 times 4 is 64. So this answer up here is 3. So we got a little practice there. And what we can see here is that problems in this first column that were up here all can be written as exponent problems. For example, 4 to the 0 equals 1. The 5 or the fifth root of 32 is 2 for the second column. Those are all root problems. And then the third column, those are all log problems. So we wrote log base 4 of 64 is 3. So when you're solving a log problem, you're really trying to find the exponent. Logs are exponentials. So let's get a few more practice problems in here. And I see in the bottom here, we get the numbers, so that's log. So we're really thinking log base 3 of 1. So to get that 1 there, we need to have 0. Because we can double check. 3 to the 0 is 1. Again, got some log problems here. This would be like log base 2 of 64. So again, trying to find log base 2 of 2. So I'm going to figure out what number I'm going to put up there. So 2, 4, 8, 16, 32, 64. That goes 6 times. So this answer is 6. Log here. So again, we're thinking log base 10 of 1 over 100. Or again, we could write that as log base 10 of 10. And we got to get that down to the bottom. And then 10 squared is 100. So this answer should be negative 2. And log down here. Log base 5 of 125. So again, trying to rewrite log base 5 of 5. 5 to what power is 125? That should be 3. So our answer is 3. All right. A little trickier on this one. Log base 32 of 2. Ooh, so now what we've got to do is somehow get that 2 to be written as some power here. So this is log base 32 of 32. To what power do we have to get a 2? Well, I know 32, the fifth root of 32, because I know 2 goes in there, or is multiplied by itself 5 times to get 32. So what I can think about here is I need like the fifth root, or I would have this as an exponent. 32 to the 1/5 power, that is what 2 is. So now that I got the match, I know my answer is 1/5. Again, think of log down here in the bottom. This would be like log base 2 of 1. So I've got to think about 2 to what power. You can actually write that out if you wanted to. Log base 2 of 2. What power do I need up here to make that 1? Well, anything to the 0 power is 1. All right, so then what we can do is we can actually use the triangle of power to help us solve these problems. And we just actually end up drawing the triangle of power for this. So, first one, draw the little triangle. If it's logs, I know this first number's got to go here, and this next number's got to go here. So now you can just change this problem around and ask the question, well, 5 to what power is 25? And that answer would be 2. So again, same thing right here. 4 and 1. 4 to what power is 1? That'd be 0. 4 and 64. 4 to what power is 64? That'd be 3. Got a 3 and a 1 over 27. Now we're looking at 3 to what power is 127? Well, I know it's moved down to the bottom now, so I know it's got to be negative. But 3 to what power is 27 is 3, so this answer is negative 3. 7 and 49. 7 to what power is 49? 7 squared is 49. Oh, there's no base there, but remember, if it's not there, it's a 10. So when we write this one, we can go 10, 10,000. 10 to what power is 10,000? Well, I'll count the zeros. It'd be 4. And this one right here, we've got, again, no base, so remember that that's a 10. And then we got 0.001, or you can think of this also as 1/1000th. So I know if it's down the bottom, I know I got to be negative 30, so it should be negative 3. (16 and 2). 16 to what power is 2? Well, that got smaller, so I know I'm really kind of taking a fractional exponent. So I got to look at, well, how many, if I multiply 2 by itself, how many times do I have to do it to get to 16? So I know it's 4, so I'm really got to take like the 4th root of that 16. So 16 to what power? If I went to the 1/4 power, that's really thinking like the 4th root of 16 is 2. So this answer is 1/4. And this last one, well, you should be able to recognize that those are the same thing and the answer is just 5, but it does fit into the triangle of power as a and a to the 5th. So then you're asking a to what power is a to the 5th? Well, it's just 5. Okay. Alright, some more problems here to help us with the triangle of power. We've got different numbers in different spots again. So, I've got the x right here, the 125 is right here, and that's 3. So I'm asking myself, what to the 3rd power is 125? Well, in this case, x equals 5, because 5 to the 3rd power is 125. The 4 here, the x here, and the 0. So we're trying to solve for that x down there. 4 to the 0 is 1. So x has to be 1 here. 4, 16 is the x. 4 to what power is 16? Well, x has to be 2. 4 squared is 16. Got a 2 here, and an x here, and the 5 is on top. 2 to the 5th is 32. So x has to be 32. 8, 1 over 64. So again, we're thinking 8 to what power is 164? Well, I know I got to get down to the bottom, so I know it's got to be negative. And to get 8 to be 64, I got to square it. So this should be negative 2. So x equals negative 2. Again, base is 10. X, 2. 10 squared is 100, so x is 100. Again, little base is 10. 10, 100,000. 10 to what power is 100,000? We'll count the zeros. X has got to be 5. 2x, negative 5. 2 to the negative 5. We'll bring it down to the bottom. 2 to the 5th is 32, so this would be 1 over 32. And our last one again, if you see the a, this would be a to the x is 15. A to the 15th is a to the x, so x has to be 15. Okay. So again, you can use that triangle of power to help you. Hopefully those were enough examples to help you visualize you solving logarithm problems. Good luck on your homework, and good luck on your assessments.